Hi. So today I'm going to talk about using GraphQL as an API mask. So essentially, let's say that you have a front end that needs to hit a whole bunch of different APIs in order to return like one data structure, right? Well, that's kind of a pain. And let's say that those APIs change on the back end, then you have to change a whole bunch of other stuff, and it kind of becomes a bit of a pain. So, one of the big things in computer science is hey, let's divide up duties, right? Let's make one thing do one thing well, the other thing can do the other thing well, and that's that. And one of the ways that I have found to take multiple API calls and condense them into one comprehensive data structure is by using GraphQL. The example that I'm going to use is calling a weather API for my local weather for like the maximum temperature today, the minimum temperature for today, and for the current humidity. So let's use an example of that, shall we? So here I am. I've created a new project for it. There's nothing contained within it. Let's do a main. So here we have a main. We save it and exit. Do it again. Cool, that works. Remember to create your mod, which basically makes sure that all of your dependencies are where they're supposed to be. So if we write this right now, this will throw an error saying that, hey, you're not using GraphQL. So let's start using GraphQL, shall we? So the first thing is we're going to have to create the fields for our query. So how do you do that? Well, we sort of establish fields, and it's GraphQL dot fields, right? Because we're going to have multiple fields associated with this. One of them is going to be min, and mostly what we're going to see is a lot of this is like boilerplate. So for min, it is of type reference to GraphQL dot string. So GraphQL is the string. GraphQL dot string is like the type of variable that's going to be returned from this, and that's within brackets. And so the type is GraphQL dot string. Use a description. Descriptions are good for your stuff. Minimum temp for the day, right? Cool. And then we have a resolve. So resolve is actually where this sort of structure is being called in some way, and in order to resolve that call, some kind of action needs to be able to take place. And that's what resolve does. It describes the action that it's going to take to resolve this variable. So what is that going to be? It's basically just a function signature. And this is always going to be the same graph, from what I can tell at least. I'm sure there are plenty of better Go engineers out there who will tell me that I'm terrible and I suck and I shouldn't be doing this at all, but I don't care. Don't let people do that. Being bad at something is the start of being pretty good at something. This is going to return an interface and an error. Definitely check your errors, kids, especially with Go. Go's error handling is actually really cool. So in here is going to be find the min temp function. Yeah. That. And from that, that's essentially how you declare a field that's being called within GraphQL, right? But I want to be able to, let's say, I want to get the max temperature and I want to get the humidity as well, like we talked about, right? So what I am going to do in here is say, hey, I want to get max as well. And, excuse me, and, nope, percent, and GraphQL dot string, because it's of string type. You can do multiple types in here. You can do int. It provides that. You can do float, right? You just have to declare the type that this is going to be associated with. So it's type GraphQL dot string. And hey, you know what? Let's be a little lazier about this. And I'm going to say, let's yank all of this. And cool. Max temp for the day. And here's where we're going to define the max temperature function. And then we are going to say, let's yank this as well while we're at it. Cool. And then we're going to say, let's do humidity here. Current humidity. Because again, we're going to come here later and we're going to say, hey, these are the functions that are going to resolve this humidity. But we have to define our fields first, what we're looking for. Cool. Okay, so now that we've defined our fields, we have to define a root query. And that root query is just kind of like the main query that's going to go out and do all of our junk for us. So we're going to define root query is equal to, it's a GraphQL object config. It's a GraphQL object config. And its name is, let's say, super duper query. Right? And its fields are going to be the fields that are listed right here. Cool. And then we're going to have a schema config, because we need to configure the schema that we're using to query. And we're going to say GraphQL dot schema con. Oop, that's not what I wanted. Schema config. Yep. And the query is going to be the GraphQL dot new object, and it's going to be a root query. Cool. And then we're going to have a new schema and an error. It's going to be GraphQL dot new. GraphQL dot new schema, and we're going to pass it that schema config. Cool. So all that's looking good so far. So we have defined our fields that we're going to be querying against. We've defined our root query. We have defined the schema config of that root query. And we have defined the schema that's being parsed by GraphQL when we declare a new schema object here. Cool. And then make sure you check your error. So if error doesn't equal nil, let's do log.fatal, because this is a fatal error. If we can't use our schema, then nothing's going to work. So that's fatal in my book. So failed creating new schema. And we're going to have our modifier in here, percent v n, a new line, and then pass that the error. Cool. And now we're checking for errors. Cool. So now we're going to say, we're actually going to define the query that we're passing this. Now, this is a query where we're not passing any arguments. You can pass arguments. I don't see how it would be useful if you weren't able to pass arguments. But this, you can actually, yes, you can pass arguments. We're not going to do that here. We can do an example maybe later on where we actually pass arguments to this schema, but we're not going to do that. And so our query is going to be very simple. It's going to be the names that we've assigned to each of these fields, right? So our query, that's the, I don't know what you call that special quote mark, but it's the one with the tilde on it. That's that one. That threw me off for a long time, which sounds silly, but it did for some reason. So we're going to do min, max, and humidity, right? Because it's got to match these field names associated with it. It should match as on a string. That's it. Well, it's a map, but same thing. And that should be there. And then that's there. So what those special quote markers do is they tell Go to treat everything, including the new lines, sort of as an exact string. I'm sure there's a nerdy Go developer out there who's going to correct me and be like, yeah, it's not, whatever. This is why I'm doing this, so I can get better. So now we're going to be passing our parameters to our GraphQL query. So we're going to say parameters is equal to GraphQL dot query params, excuse me, right? And the parameters that we're passing it are our schema, which is our schema. And we're also going to be passing it the query associated with it. So this is actually kind of the meat of what's happening with this GraphQL library. We're telling GraphQL that we have a schema and we have a query associated with it. So take that query, do some magic, and then dump it onto our schema, so to speak. Query, request string, excuse me, request, where the request string is just going to be our query. Cool. So now we're going to say R for request. In Go, I see a lot of times people using single letters as variable names. I'm actually not really a huge fan of that. Maybe it's just because I've done a lot of Java in my life, but unless it's some kind of iterator or something like that in a loop, use more expressive names. Here we're just going to call it R just because we're doing an example, but it's good practice and to use expressive variable names in programming. A book that I really recommend is Clean Code by Robert Martin. He talks a lot about that. It's really, really good. So we're going to say GraphQL.do because we're doing something now, and we're going to do those params. And then we're going to say if the length of r.errors, because it's going to return an error for each one of those resolve functions. And so we're telling it, hey, if the list of errors is any larger than 0, print those errors out and make it fatal. And that's what we're going to do right now. r.errors, excuse me, is greater than 0. Then we're going to do something. Let's save real quick to make sure we don't have any compilation errors. So we're good. So log.fatalf, failure of execution, right? Then we're going to say mod plus v, and then new line. String formatters are really good in Go. They're very C or C++ like. I really like them, and they make my life a lot easier. So we're going to say r.errors, right? And it returns, this is why I love you complete me. It returns a slice of errors, so to speak. Cool. So once we have done that, we're going to say our JSON. Again, not terribly descriptive, but you'll see what I'm doing. So we're going to say go import encoding plus JSON. I love the encoding library in Go. It's so, so good. But then we're going to say new JSON.marshal, and we're going to marshal R onto that guy right back there. This does return an error. We're just going to ignore it for now. Don't ignore your errors, kids. This is bad practice. But like I said, this is an example. So, and then we're going to say fmt.printf, and we're going to print out mod plus s, I want to say, s for string, and then new line. And we're going to say rjson. Cool. So now we've created pretty much everything we need to be able to make a query. The problem here is that there's no functions being resolved on that query, right? So we have comments out here for our resolve functions. Now we get to write those, which is super cool. So we're going to say vsplit. Let's just say endpoints. Endpoints.go. Cool. And now we have a new one. So at this point, this is where you're going to have to start handling sort of the data structureness of your API call. At this point, this is kind of academic. It's not something that I would necessarily feel like you super need to go over, but I'm just going to give you an example just as something for your own edification to kind of see what kind of things you need to return from this. So as part of that, I've actually already had the structure created. All you have to do is to take the JSON that's being returned from this API, dump it into a JSON to Go struct conversion. You can easily Google that and you'll get a great response. Somebody actually created that. So here, it's a massive struct that's returned by this API, but it's really, really fantastic stuff. And I highly recommend checking out that JSON to Go struct, because this is like a pain to construct on your own. Don't even bother with it. If you already know what the APIs are, then you're able to get the data structure associated with that as it's returned from the API call. Take that, dump it into either the JSON or XML if you're dealing with XML, which I'll actually be doing a video on later on here because it's still very, very common within the production code world. Just dump it into there, and then it'll create a struct for you that you can instantiate, which is what I did here. So what are we going to do? So let's create a function that returns the humidity for today. So we're going to say func get humidity. Capitalize that first letter. We want it exported outside of this. We're not going to take anything. Not going to take any arguments, but it is going to return an interface, aka a generic, and an error. Cool. So once we've done that, we need to import net/http because we're making a call or a get, so to speak, an HTTP get. Cool. Done that. And we're going to say the response and error is equal to http.get. And we're just going to supply the string for the API call. So https semicolon or colon / wttr.n / the city that I live closest to is Minneapolis, so Minneapolis, and we're gonna return it in a JSON format. Check out this API, wttr.n. Really cool weather API, and I use it all the time for testing stuff like this because I know it's gonna return stuff in JSON. It's pretty much always up. And it's free to use. Then check the error. If error doesn't equal nil, you'll see the lot in Go. Go has a lot of boilerplate like this. I think it's okay. Log dot printf, and we're gonna say HTTP get for humidity. Failed. we're gonna say bod plus v new line. Do that, and then we return the response and the error. Excuse me, we'll just return blank and then error. It's going to complain if I don't have that extra bracket there, which is fine. And then we're going to say defer that because HTTP GETs are concurrent calls. So defer response dot body close. Cool. So defer is just saying, hey, when this, wait until this this response is handled and done, and then we can exit the function. You'll notice that a lot of times in Go, you'll see that defer, and it's just because Go functions, Go routines can actually execute after like the function that calls them has exited. So then you essentially get like a dangling Go routine. Use a defer. Cool. So we have that defer in there. So we're going to say weather is equal to a new weather structure. Cool. And we're going to say JSON.new decoder. And we're going to decode the response.body. Decode. And we're going to put that on weather. Oh, we need to import log. Go log. Declared name. Yeah, whatever. Just ignore that for now. And then we're going to return the JSON decoder returns an error. So take care of that too. We're going to return the weather dot current condition, first element of the array, and the humidity and error. And that should pretty much work. So now that we've done that, let's start doing our function stuff. So here we're going to say return the get humidity function. And that returns, guess what? An interface and an error. And we pretty much have to do the exact same thing for the other two functions. So what we're going to do is we're going to copy all of this. And we're going to do it again. And we're going to say get high temp. And we're going to say get minimum temp. And I mean, they're pretty much the exact same thing. So for get the high temp, get temp, there we go. And we're going to say weather.weather 0th element. And we're going to say, get me the max temp in Fahrenheit. Because that's what we're looking for, right? Yeah. Cool. here we're say for min temp, and then don't want to do that. Space there. Or say whether 0th element, not O element, 0th element, dot min temp Fahrenheit. And that's what we want to return. And yeah, I mean, that looks fine to me. I don't know why this is throwing an error. Sometimes Vim and the syntax highlighting can be a bit of a pain, but that's okay. So now let's go in here and fill this stuff out. So here we're going to say we don't return. For here, we're getting the minimum temp for the day. So we want to get the get in temp. Do that. And we want to return get high temp. So that should be good. So let's do a go mod tidy. And let's do endpoints. Everything looks good. Let's see why is it complaining? This is the same thing I don't like about a lot of programmer videos. They show it just being like a super clean, fantastic thing, and in reality, you're going to have to debug a whole bunch of junk. Ah, that's what I did wrong. This isn't a field. This is a field. So all of these have to be fields. So that's a field. It's not a string. The type associated with that field is a string, but the field itself is a field. So easy mistake to make. And my error compilation showed me what was going wrong in a very expressive way, which was really, really nice. So, I mean, all of this looks good. Let's run it and see what happens. All right, so we're complaining on endpoints 121. That's probably why. Let's just get rid of that. So the reason it's complaining is because I didn't capitalize the first letter, which means that I don't know why that's complaining. Like, typically JSON decoders return an error, but with these in Go, like I said before, functions that are exported outside of the package or variables that are exported outside of the package, essentially public variables, I guess, in any other language like Java, the first thing has to be capitalized. Go figure. Okay. See what happens. Hey, what do you know? Look, we have our current humidity, we have our maximum temperature for the day, and we have our minimum temperature for the day. Isn't that neat? So at this point, we essentially have a fully functioning GraphQL API. Now, if I wanted to come in here and say, hey, you know what? I don't want this to be function main anymore. I want this to be function Minneapolis weather. I could do that. And then I could have a main somewhere else that calls this function and returns a data structure, type weather struct that contains the humidity, the minimum temperature, the maximum temperature, and that's what's returned. I could also come in here and using Gorilla Mux make a RESTful API, and that RESTful API returns that JSON, which means you've created an API mask. There's a ton of different things that you can really do with this, but the things that really show you the power of GraphQL are frankly have to do with main. And main, being able to define fields that you're going to query, defining the root query, the schema config, and the schema that's being returned, and then returning that in a JSON that you can marshal and unmarshal, that's awesome. And this should actually be a really good starting point for you if you understand anything about how to make a RESTful API in Go, all that kind of stuff. It's agnostic as to the source of the data that you're looking for. I could just as easily come in here and say, hey, in this resolve function, I want that to be a SOAP call. Well, on the back end of that get humidity function, I can go in there and I can create a SOAP call. As long as it returns the interface which contains the information that I'm looking for and an error, those are the two return types of the function, it'll work. It is 100% agnostic. Thanks for coming on this journey with me. This was super interesting. I love talking about this stuff, and I've got more videos planned just around stuff that I'm interested in. I hope you and yours are doing well and that life's treating you well. Yeah. Thanks.